Delia Milliron is working to open new windows into our understanding of nanomaterials, including the new area of plasmonic oxide nanocrystals. Her goal is to develop a robust chemical knowledge of how things work, with the goal of ultimately providing solutions to real-world needs. One such solution uses the unique properties of these nanocrystals to dynamically control the heat and light passing through windows separately, letting in heat in winter and keeping it out in summer. A spin-off from her research is working to bring these more energy-efficient and cost-effective windows to market. For her research insights, excellence in teaching, and commitment to science, the Welch Foundation honors Delia J. Milliron, Associate Professor at the University of Texas at Austin, with the 2017 Norman Hackerman Award in Chemical Research. While her work with windows may benefit consumers in the near future, most of her research stays at the more fundamental level. Her goal is to explore problems and create new insights that ultimately can drive new engineering breakthroughs.
I think that fundamental research and the knowledge that we gain is the basis for developing all sorts of new applications, and it may offer solutions in an area that I'm not even aware of the problems. So that's another thing I spend time doing, is trying to better understand the problems in different application spaces so I can recognize connections between the fundamental work that we're doing in the lab and a new application area where it could be beneficial.
What really set Delia apart from other faculty, other people that we were looking at, is that she's trained, fundamentally as a chemist. And so she has this desire to explore the properties of materials and to really understand at a deep fundamental level what controls them. But she has the mindset of an engineer. And so the idea is that, yes, you want to understand what gives those materials their unique behaviors, but then you want to be able to creatively think about how do you incorporate that knowledge to create new technologies.
This focus means she often works collaboratively, both with colleagues across the university and across her group.
I'm not in the catalysis field, but I'm trying to learn about how our plasmonic materials could be beneficial to tune catalytic outcomes, perhaps even dynamically, or could improve the sensitivity of different kinds of detection schemes. And those realizations can lead to new collaborations with people who are experts in those fields, and also to renewed focus on different aspects of fundamentals that maybe we don't understand well enough to choose or design a material for that purpose that we hadn't thought about before.
Dr. Milliron currently is studying how nanoparticles can organize themselves in a fluid into gel networks. What aspects of the inner nanoparticle forces control the network structure? And how does this influence the optical properties of the gels? The answers could have implications for batteries, supercapacitors, and fuel cells.
She has this excellent foundation as a scientist, but then she's always probing and exploring new ideas, trying to think of new and creative ways to apply chemistry to new problems, solve engineering solutions. She clearly enjoys what she's doing.
Away from the lab, Delia enjoys her 2 Cavalier King Charles Spaniel puppies in a modern home whose interior she helped design. When not working, she enjoys outdoor pursuits, including running and diving, and often avoids Austin traffic by biking to campus.
The time that I spend biking to commute is a really good mental reset for me. So it's a chance for a little mental break and to pull my mind away from the details I've been worrying about, and to think more broadly and allow fresh ideas to come into my mind.
Delia's approach to the chemistry of cooking echoes her experimental approach in the lab, if pursued with less scientific rigor.
I love to cook. I also love to eat, so they go together pretty well. I like to try out different flavors. I'm pretty open to all different kinds of flavor profiles, and I enjoy exploring different combinations of spices.
One of 3 children, Delia grew up in upstate New York, where her father was a physicist who worked as an engineer, and her mother was a psychology professor. Always interested in science, Dr. Milliron attended Princeton to major in chemistry and earn a certificate in materials science and engineering. After earning her doctorate in physical chemistry from UC Berkeley, she worked for IBM and then Lawrence Berkeley National Laboratory. The opportunity to teach drew her back to full academia, and she accepted a position with UT in 2013.
Mentoring students is absolutely my favorite part of the job. Mentoring them, watching them become critical thinkers and learn to be scientists has been the most satisfying part of my job from the outset. And when they have their own research idea, design an experiment, and ultimately achieve success, everybody in the group is celebrating, jumping up and down, usually literally.
In addition to her group, Delia teaches undergraduate classes, including materials for chemical engineering majors.
Her expertise is so broad. So she starts on one hand from the fundamentals, really can explain those clearly to students. And her training as a chemist and then her work in technology helps students to understand how you can begin from the fundamentals and then build something that's really useful and that has great engineering functionality.
In Dr. Milliron, Assistant Professor Sean Roberts has found both a mentor and a collaborator.
Delia is able to wear so many different hats. She has a research group that brings people in from material science, from chemistry, from physics, theorists. So she has a group that's a really diverse grouping of people. And so she really knows how to bring the right tools to a problem. And she also knows how to tackle really interesting problems. She's a very inspiring person, and she's been a great role model.
Dr. Milliron says that achieving that new insight or breakthrough, while an exciting accomplishment, is just one milestone in the research process.
We want to be critical and examine all the aspects of the problem in a way that will make our result meaningful to the whole community and hopefully stand up under future developments and future critical review and use, building on that result by the community, because that's where you can have the most impact and really help science go forward.
With Delia, if you look across her portfolio of papers, so many of those papers, it was the first time that anyone had created a material like that, or it was the first time that someone had been able to carry out an experiment to measure that property. So nothing that they're publishing is wasting somebody's time.
For her invaluable contributions to science, the Welch Foundation is pleased to recognize rising star Delia J. Milliron with the Norman Hackerman Award in Chemical Research.